Welcome back, everybody. Yesterday we took a look at how to find slope of a line. Remember, that was the angle, or how steep is the line, and we did that when given a line on a graph. But what if you don't have a graph? What if you only have 2 points? And that's going to be today's topic, the slope formula. However, before we get into that, let's do a quick review of yesterday's lesson. That is, slope is rise over run. Rise being the change in y, or how much do you go up and down in the y direction, and run being the change in x. How much do you go in the x direction? On the right, we have the graph of a line, and 2 points on that line, located at 1, 1, and the second at 3, 4. Let's look at the rise. From 1, I go up 3. And then, to get to the point, I have to go over 2. So 3 over 2 is our slope. We can think about this in a slightly different way. Rise, also called change in y. So my question is, how much did my y value change when I went from 1 to 4? So we'll subtract the y values. 4 minus 1 gives me 3, or the rise. And also, how much did I change in the x direction? How did I go from 1 to 3 from the 2 points? Change in x. 3 minus 1 is 2. So it's no accident that when doing the subtraction, 4 minus 1 and 3 minus 1, we end up with the rise over run of 3 halves, identically the same as the slope we had above. So from looking at it in a slightly altered way, we can see, using subtraction of y values, like we did with 4 minus 1, and subtraction of x values, like we did with 3 minus 1, we can calculate the slope of a line without even needing to look at the graph. So, we're going to look at what we did. We had 2 points. We didn't even need the graph for them. Point 1, 1 and 3, 4. We'll call the first one point 1, which is an x value and a y value. And the second one we'll call point 2. It's an x and a y value. Now I'm intentionally changing the numbers to x's and y's. This way we can be talking about any point to make a formula. The problem I see here, however, is I get 2 x values and 2 y values. I need to be able to tell them apart later on. Since the top one belongs to point 1, I'll call them x1 and y1. Since the bottom values belong to point 2, I'll go ahead and call those x2 and y2. So, quick reminder. Point 1 was the same as the coordinate 1, 1. Point 2 was the same as coordinate 3, 4. So to make things easy, we'll do large numbers minus the small numbers. The large numbers came from point 2. So we'll do point 2 minus point 1. Once again, what are we doing? We saw on the last slide that using subtraction of y values and subtraction of x values, we can calculate the slope of a line without a graph. So, here we go. Slope is rise over run. Rise is change in y. So I want to look at the change in the y values. Subtract them. That's how you find the change. y2 minus y1. I subtract the y values from each point. Run is defined as the change in x. I'm talking about the x values of the 2 points now. I want to look at how they change. And to find that, you've got to subtract them as well. This, ladies and gentlemen, gives us our slope formula. y2 minus y1 divided by x2 minus x1. Couple things to note. y2 and x2 are on top of each other. They both start off their portion of the expression. And y1 over x1 are also lined up. It's important to be consistent. If I start the equation with y2 on top, I start the equation with x2 on bottom. Changing that can cause errors in your sign, such as a positive or negative sign error. I'm never going to ask you to show where the slope formula came from. This was just kind of behind the scenes type stuff. But what's important to know at this point is that is your formula, y2 minus y1 over x2 minus x1. Let's take a look at how to use it. So you might be given a question that looks like this. Find the slope between the points 1, comma, -2 and 4, comma, 6. Before we start, you're going to want to assign one of these to be point 1 and one to be point 2. It does not matter which is point 1 or which is point 2. We just want to stay consistent. So we'll call the left one point 1, the right one point 2. All we've got to do is substitute our x and y values. Formula says y2, that's 0.2, and the value of y. So y2 is 6. x2 then would be 4. Now we got to do 0.1. y1 is the y value from 0.1. That is a -2. The x1 then is +1. Please note I did not change the negative signs even though I plugged in a negative point. A negative for the formula and a negative from the point. So long as you write every detail down, you should not have a problem. In fact, we should do that here. Opposite of a negative. We should change that now to a positive. All we have to do is simplify the top, simplify the bottom. 6 plus 2 is 8. 4 minus 1 is 3. So the given points would have had a slope of 8/3. I would consider this to be a steep slope. You're going up 8 units and over 3. You're going up a lot more than you're going over. The second example. Same thing we just did. We'll call the point on the left point 1. We'll call the point on the right point 2. Substitute point 2 in for y2 and x2. So y2 is 4 and x2 is 3. We're now left with x1, y1. That says 0.1 to me. So y2 is 8. x1 is -3. Again, I see opposite of a negative. Let's rewrite that as a positive. So we have 4 minus 8 equals 3 plus 3. All we have to do is simplify the top and simplify the bottom. 4 minus 8 is -4. 3 plus 3 is 6. The slope of this line is -4/6. I look at this and I see an even number on top, an even number on bottom. We can simplify this. That's the same as -2/3. So the slope of this line is -2/3. Please note it's a negative, so this is what we would have as a downhill slope from left to right. It goes down. Down 2 units, over 3 units. And this covers our example of the slope formula. Big thing to know, slope is y2 minus y1 divided by x2 minus x1. It came from the idea of rise over run. The change in y divided by the change in x. All you're doing is subtracting your two y values, subtracting your two x values, and you're good to go. Now that we know how to do slope, tomorrow we'll put things together and figure out how to write the equation of a line.